Welcome back to PV Online, and today we're going to take a look at projectile motion. Now, we're going to define projectiles as anything where the only force acting on it is going to be gravity. So we've already dealt with free fall, so this would be an example of a projectile. But now we're going to take a look at it a little more interesting in that what if we throw it at an angle or if we throw it horizontally off of a cliff? All right, so the key to remember is that for it to be a projectile, the only force acting on it will be gravity. Now, this is going to be the part you have to write down. These are the key ideas as far as projectiles go. And the first is that the horizontal motion of a projectile doesn't change because there's no force acting on it. The only acceleration that a projectile is going to experience is going to be that due to gravity. You see how the marble goes the same distance each successive second? And that's because it's moving at a constant velocity horizontally. Now compare that to the vertical motion. The vertical motion we're accelerating, and that's because we're going to be under the influence of gravity, which is a value of 9.8 meters per second squared. All right, we have this example of a cannonball. And if you were to launch a cannonball, and if there was no gravity, we know that that cannonball would just continue in a straight line forever. But there is gravity. Now, if we were just to drop the cannonball straight down, all of a sudden the distance would get successively bigger because gravity is causing it to accelerate. The net result of that is we've got the horizontal motion, which in this case is going to be the green dots. We've got the vertical motion, which is going to be the red dots. And the result of that is going to be the blue dots, the actual motion of the projectile. So we're going to be breaking up the components into what's happening to the projectile horizontally and vertically. Horizontal, constant speed. Vertical, it's accelerating. The shape of a projectile is called a parabola. And that's just going to be the curve that it makes, and you've heard that term in your math class. And so that's going to be the shape of a projectile. All right, so we have an example of a girl dropping a ball, and if she drops it straight down, it's undergoing free fall. The only thing it experiences is gravity, and you can see the distance that the ball falls each successive second. Now take the example of the cannonball, which is launched horizontally. You're going to have two motions going on now. We have the constant motion of the horizontal plus the acceleration of the vertical motion. The net result is going to be this path over here. Okay, so no matter what, gravity acts the same, whether it's got an initial velocity or not. This is an example of if you had a marble and if you dropped it at the same time you launched a marble horizontally, look at what happens to their vertical positions. Their vertical positions are going to be the same because gravity acts on them the same in both cases. Again, their vertical displacement is going to be the same whether you launched the cannonball horizontally or whether you just dropped it. All right, I would make sure I had this written down. These are such big ideas. The horizontal portion of the motion experiences no force. The vertical motion does, and that's gravity. That's the earth pulling on that cannonball. The horizontal motion experiences no acceleration. It's moving at a constant velocity. The vertical motion experiences gravity, which has a value of 9.8 meters per second squared. The velocity in terms of the horizontal motion is constant, whereas the vertical motion is changing 9.8 meters per second every second. Now take a look at this. These arrows represent the horizontal and vertical components of the velocity. What do you notice is happening to the horizontal component of the velocity? Do you see how it's staying the same? But now take a look and just focus on the vertical component. What's happening to the vertical component each successive second? Now down here, you've actually got the numerical values. Do you see how the horizontal component is staying at 100 meters per second? But look at what's happening to the vertical component. It's changing by 10 meters per second every second. Remember, we can approximate g to be 10 meters per second squared. Now, an interesting phenomenon occurs when you launch it at an angle. Notice how the horizontal component doesn't change. That horizontal component doesn't change. The vertical component does change. It's constantly getting smaller. It starts out at 60 meters per second. It gets smaller and smaller until it reaches 0. Then on the way down, it starts getting bigger, but it gets bigger in the negative direction. So now if you're a football player and you want to kick off the ball as far as you can, which angle would you choose? Now watch what happens. We're going to launch a projectile from a moving car. Why do you suppose that the projectile is going to land back in the bed of the truck? Remember, you've got some initial horizontal velocity. That horizontal velocity is the same for both the truck and the projectile. Now, the only difference between the package and the plane is that the package is now going to have a vertical component, but that will have no effect on the horizontal component of the projectile. All right, do you know why the horizontal component remains constant? Gravity only acts down. Gravity only acts vertically. Why does the vertical component of a projectile undergo change? It's gravity. All right, we have a projectile. Look at what's happening to that horizontal component during the entire trip. Do you see how the horizontal component is staying at 10 meters per second? Now we have two projectiles launched from the same height, but the one on the right had half the initial velocity as the one on the left. Now pay close attention to the time. Look at how the time is the same for both of them. So time is independent of the velocity, the initial velocity. Now we have one where the one on the left was at a higher height than the one on the right. Let's see how that affects the time that it's in the air. So the time for the projectile is strictly dependent on the height from which it was launched. All right, you have a lot of information. Good luck on your assignment. We'll see you next time.